Okay, today we are gonna see how to process X-ray photo spectroscopy data, photoelectron spectroscopy data. So I'm using a CasaXPS software, but you can use any of the other available softwares. And just click on File, open your data file, which you will get from the instrument. I'm gonna process this data file over here. Okay, so now I have two spots scanned on the same sample. So this is the first spot, this is the second. You can have multiple spots. I'm going to start with the first one. The very first step of this processing is to calibrate your data. So for calibration, what you need to do is you need to click on this processing, go to calibration, because some of the peaks might be shifted. For example, this one, if you click here, this is the carbon peak. The carbon peak is usually at 284.8, and in my spectra it's 282.4. So I want to tell software that it has shifted, corrected. Okay, so if you don't know the peak value, the binding energy value of a particular element, you can go to this website, XPS Simplified, and click on periodic table, element table, and then click on your element. For example, here we are talking about carbon. So its value is 284.8. I want to tell my software that the peak should be at 284.8. So when I click here, the software automatically picks up that number. Now it asks you what it should be truly. It should be truly 24.8. And then I click on regions. So because I have no components yet, I just have to click on regions. You can select both if you want, and you can also select these two spots at the same time and then click apply to selection. I just want to do it for the first spot only. Click on apply. Now it has been applied. If you click here again, you see it's showing 284.79, which is what we were wanting it to show. Okay, now the next step is to find the peaks. For that, you need to click in here, library. So now the first method of finding peaks is element table. In element table, you can just click on some random peak. Let's say this one. We know this is carbon from experience. Okay, and this is carbon here. It shows you a list of the elements which could be nearby, because sometimes a shift happens. Okay, for example, this one, it's most probably oxygen. Yeah, there's oxygen, because it's very important for you to understand what your sample is, so that you know what elements to include, what elements not to include. For example, gold. For sure I don't have any gold, and there are other methods to verify if there is gold or not. You can look for the RJ peaks, you can look for the other peaks to confirm. So for the time being, we'll not be using element table, we'll be using periodic table. It's one of the same thing. It's just, I just find it easy to use periodic table. Click on find peaks, it will find all the peaks. So this is, I mean, extreme case, and I don't have these elements in my sample at all, so I just want to exclude them. Okay, okay, looks good. Once you have done that, click on create regions. Now software has taken this as a region, and using relative sensitivity factor and area under that peak, it has calculated the amount of the element in my sample. So we're gonna refine this. Right now it's a complete mess over here. I'm gonna refine it. So close it, open the quantification here. Once you have done that, it will show you the list of the elements as different columns here. Okay, the first region is oxygen. Click in there. If you click there, it will show you the zoomed onto that peak. This is the start of that region. This is the end of that region. So if we zoom out a little bit by this button, you can see it's the region is starting from here and ending here. Software is calculating area under this peak and multiplying it by the relative sensitivity factor, which is for oxygen 1s is 2.93, and then giving you the oxygen as 26.43%. Okay, I can adjust it. For example, it's too big. Okay, this looks fine. Then move on to the second element. This is carbon. Now zoom out a little bit. Look at this one. So this is a bit complicated case. Okay, so for the time being, I'm gonna delete the carbon and potassium, and we'll come back to it later on. So I'm gonna delete carbon, and because it was overlapping with potassium, I'm gonna delete potassium too, because they are difficult to analyze in this particular situation because the overlapping peaks, and software is not able to tell you whether it's carbon or whether it's potassium. So the next one is nitrogen. So this is nitrogen. You can rescale the y-axis by clicking here. Okay, this is the nitrogen. So you can zoom out a bit. There is something left to the nitrogen. Okay, so I don't want that to be included as nitrogen, so I'm gonna adjust it just a little bit. Oh, this looks fine. Okay, so moving into the next one, fluorine. Zoom out a bit. Sorry, rescale the y-axis first, and then zoom out. It looks fine. Okay, moving on to the next one, copper, and then zoom out a bit and rescale. Okay, the copper is looking like it is having some component here. Okay, so if you're not sure whether it's copper or not, you can, let's zoom out a bit. Okay, you can zoom in by dragging and drawing a rectangle and clicking inside the rectangle. Okay, now let's go to this website because I find this website very useful. Click on element tables, go to copper. Where's copper? Where's copper? Where's copper? Here. Its copper is 933 electron volt binding energy, and this is an important and distinguished factor in copper. You see, the copper peak has significantly spin orbit split, which is 19.75. Do I have 19.75 different peaks? So look at this peak. Click here. It's 954.7, 934.7, 954, 934, approx 20 electron volt, which is right. So these are in fact copper. So there are various ways to confirm whether this is copper or not. This was one of them. So I know for sure there's copper. Okay. So now the other thing is, this is copper 3 by 2, and this is copper 2p 1 by 2. Okay, this is the spin orbit 1 by 2, this is the spin orbit 3 by 2, and the software is saying this is copper 2p. So right now software is thinking that this is all copper 3 by 2 and 1 by 2, but no, it's not. The copper 1 by 2 is outside of that region. You can either include that in, or what you can do is you can tell the software that no, this is not copper 2p. You can tell it include a hash in the beginning, otherwise it won't work, and then tell it is 3 by 2, not 2p, which means including 1 by 2 and 3 by 2. Okay, now it changes the RSF, and it will also change the value here. Okay, now it's 3 by 2, it's 2.21% in my sample. Moving on to the next one, sodium. Zoom out a bit. The background looks weird, but since sodium, how much is it? It's 0.2. It doesn't matter that much because it's very small amount. It was a big peak. If it was a big peak, it's I'm gonna then in that case I would, refine that, but I think it's fine in this case. Next one is nickel. Zoom out a bit. Now similar to copper, nickel also have 2p 1 by 2, 2p 3 by 2, and my software is saying, oh, not my software, it's CasaXPS developed by Casa. So it's nickel 2p. It's thinking that this is all the region it has. No, I'm gonna adjust it a little bit. Okay, this is fine, and then tell the software that Okay, so put a hash in the beginning and then tell it it is 3 by 2 and then zoom out a bit. Okay, this looks fine. Moving on to the next one, iron, zoom out a bit. Okay, so in this particular case the background is not good at all. What about iron 2p? It's 3.92. You can change the background type. You see, it's a background type. Let's go to iron background type, and you can use you can put S for Shirley background. Looks good, better than before because there's a lot of background noise. You see, all of my data is going up here, and if I use the flat background like the horizontal line as a background, it's gonna be totally wrong. So I need to accommodate that background noise, and I think for my sample this is fine. If you want, you can change the background type to U2, or you can use a linear background. This is a linear line. You can also use linear. For linear I just pressed L and then enter. For U2 I guess you have to type U2 then press enter. It's I think there's a space between U and 2. Yeah, space between U and 2, and then it's a U2 um, background type. I'm gonna use Shirley because I like that one. You have to, particularly do detailed research about whether you can use Shirley background on a metallic peaks or not. It's highly, complicated area because sometimes you can't just pick one background. You have to do the research and find whether you can do that or not. Okay, so um, that we can discuss in another video. So for example, in this one we can just keep it as Shirley. The next one is aluminum. Okay, zoom out a bit and see, aluminum is total mess. We have aluminum, copper, chromium, nickel all at one place. And let's check the website because in this particular case it helps. Element tables, aluminum. Where is aluminum? This one. And it's 72.6. Do we have any specific? Okay, their spin orbit are this different, which is not much. It's less than 1, so I don't think we can see it. Let's see. Yeah, it's not visible. Okay, this is 77.2, 75. No, it's 3 electron volts, so it would be here and here, very close to each other. So I don't think it's and one more thing. This is um, because I told you this is the history of the sample plays a very important role here. So I want to see whether my sample had any aluminum in it or not. Okay, so my sample, let me just quickly, okay, my sample is histoloy N, histoloy N. I'm gonna see its elemental composition. Okay, so yeah, this website, and come on, I can wait. Okay, this one. Look, let's see. Do we have any aluminum? No, not at all. Do you see any aluminum? No. Nickel is 71%, molybdenum, chromium, iron, silicon, manganese, tungsten. Oh yeah, aluminum. It's less than 0.5. It's a very, and it's not just aluminum. It's aluminum plus titanium. The combined percentage is less than 0.5. So I'm not gonna have that in my spectra. So I'm gonna delete the aluminum. Okay. The next one is aluminum 2. Next one is chromium. So click on chromium, zoom out a bit, and see whether it's just chromium or it's copper. OJ LMM. So chromium 2p. Okay, there's something weird going on in here. A rescale. Because these are two peaks, I don't know why this peak is. Okay, because this is copper 2p, sorry, chromium 2p, which means we should include 1 by 2 and 3 by 2. Okay, so I'm gonna keep that and zoom out a lot. Okay, so I have almost calculated the elemental composition of my components and regions. So now it's time the for us to export the data. So I don't like this graph. What you can do is, if you just want to show it to your professor, you can refine this graph. You can get rid of those lines, and you can get off residual at the top, and you can also go to library and periodic table. You can clear all elements. Okay, and then you can click on regions again. Okay, I just want the name of the elements, and there's one more thing where you can get rid of these things. Oh yeah, it's there because we have this tab open. Just close this. This is a very refined view, but still, I don't want this table to be on top of those peaks. You can move around this table by using the processing. Click there, click here. So now you can oh, I'm sorry, not this one. That's why I was saying, oh, where did the option go? So this is the one, pencil. It's high annotation. Click there. Now you can move. You see that red box? You can move around your table now. Okay, let's close it. This looks fine. Now you can go file and print preview. I don't want this text, and I also don't want this text. So close this, file, print setup. Okay, okay, this looks fine. And then file, um, print footnote, note, not. Just delete this. I don't want any footnote. Okay, now file, print preview. We got rid of that. And I also want it to be a landscape mode. File, print setup, and I want landscape. Okay, file, print preview. This is very, very good. You can just print it, send it to your professor, or you can discuss it with your professor, and that's all for printing. But what I would like to do is, I would like to plot it in other software, for example origin. Okay, because I don't like this graph. I want to have more control on my graph. Okay, so what I do is I export the data from here, the raw data of these peaks. So what you can do is, you can click here on save. Sorry, it was let me find, yeah, this one, save tab to ASCII to clipboard. Click there. So this is the raw data. Okay, we're gonna save it, and I've already saved it at this one. Okay, so I'm not gonna rewrite it. Cancel. Once you save it, I'm gonna show it to you how it looks like. Okay, okay, this is what it will look like. You will have the kinetic energy, binding energy, CPS, and background. So you need to plot binding energy with CPS. Forget about kinetic energy and background. If you want, you can plot it as kinetic energy, but what I like to do is plot CPS and binding energy. Okay, so this is about exporting the raw data. What about the stable? Yeah, you can export it from quantify. Click there, report section, go to report section here, and then we have regions and components. So if you click regions, it's going to only export regions. If you click on components, it's going to only export components of carbon and potassium. It's not showing up here because it is the component. You can rename it. Go here, go to white here. Did I delete it? Oh, sorry. I actually forgot to include carbon and potassium. I told you I would. Uh, I will be discussing it at the very end. Okay, let's do that. Yeah. So let's zoom on to that. I almost forgot. Sorry about that. Okay, so now we're gonna create a region around this because these peaks are unidentified. We're gonna create a region. So software has created a region around this area. So this is blank, so I'm gonna adjust that. Click and drag here and click and drag here. Okay, so this is the region. You can turn on that area by clicking here. So we're back to previous view. Okay, now the name of this is white. I don't want white. So this is potassium and carbon. Okay, it's potassium and carbon. And then go to components. Now, then go to components. Now I want to tell software that, okay, in this region, I have two peaks, which are components. In this regions, I have two further components, which are overlapping with each other. So what I want you to do is click 2 times on create or click 1 time on create two. It's one and the same thing. Okay, once you do that, you can find this is the first peak, this is the second peak. You can click at the top of first peak or any peak and drag it to the top of the other peak. Okay, I hope this makes sense. So after that, you need to click on fit components and then check whether it is fitting properly or not. So this is almost okay fit, almost okay. You can adjust the constraints. That's the other whole other um, video talk. I'll make another video about, you can constrain one peak should be half of the other peak. You can also constrain one peak cannot go this far away from the other peak position. You can have position constraint. You can have full width at half maximum constraint. You can have percentage of concentration. Sorry, you can have the area constraint. So the pink boxes here cannot be changed. You can tweak them. The only adjustable things are here. Okay, so you cannot adjust asymmetrically asymmetry index, or you cannot adjust the percentage concentration. Okay, so once you have created the regions and you are okay with them, you can adjust them to better fit it. You can also use simplex method if you want. And I know this is potassium. If you're not sure, you can go back to library, okay, and go to periodic table, bring back the potassium. So you see it's potassium. So but I'm gonna tell the software that it is potassium. Put a hash sign in the beginning. It's potassium 2p, okay, and then press enter. Similar for the other peak, it is hash carbon 1s, okay, and then you can turn off potassium and look at here. This table is showing you the regions only. We don't want that. We want regions and components. Okay, so let's just zoom out, reset the focus, and delete this table. So we're gonna go to tile annotation, select it, delete it, gone, and then go to quantification. I want to display in the table type, select both as regions and component, both of them, and click apply. Okay, then go to annotation history, select that table, and now you can drag it, bring it over here. Okay, that's it. So now you have regions and components. So oxygen, nitrogen, fluorine, copper, sodium, nickel, iron, chromium are regions. Potassium and carbon are the components. Okay, now once you're satisfied with this, what you can do is you can just get rid of these lines. Okay, click here again, click here again. That's it. Okay, so one time you click it, it will just display the regions. Again you click it, it'll take away the regions. Then it will bring back the regions and the name of the elements. I mean, you can play with this button and see what fits do you need. Okay, so now the final, now you can just go and print preview. You can just print it. Okay, we missed the carbon and the potassium, and now we have included that in the spectra too. Now we want to export this in in a tabular form. For that, you need to open the quantification, go to report section. We will select on regions and components because we have two components now. Okay, so click on regions and components. It will show you this table, oxygen, all the elements with the atomic concentration. You can click on save. Okay, I like to save it as it is the report of my sample code, and then click on I like to have report at the very end. Okay, it is report, and then save it. And I like to save this processed data, okay, because if I just save it on the previous raw file, I'll overwrite the raw file and I will never have that back because I changed to the original file. So what I can do is, this is the original file I'm working on, but I don't want to save my processing onto the original file. So I'm going to save it as with the name change to it's processed. Okay, then save it. That's good. Now let's have a look at the calculated report, which is KB report here. Okay, so that's the report we exported, and this is the raw data we exported. So we can just plot this raw data and use this to have in the form of bar chart or pie chart to show how much is the percentage of oxygen and carbon, different elements in your spectra. I hope this helped, and if you have any questions regarding XPS, uh, please comment below. I will try my best to answer it. Thank you so much. Have a good day.